Hi guys, it's my pleasure to welcome each and every one of us to my channel of Honest Sciences and Mathematics TV channel. I'd like to kindly request new members to subscribe, engage us in the comment section, and also ring that notification bell to be getting updates on various uploads. Now, in this particular discussion, I'm going to look at the concept of electric charge, and this is going to assist us build up on the whole concept of the aspect of electricity and magnetism. Now we are going to borrow from a few concepts which we have learned, especially on the concept of atomic structure, which is going to give us a clue on basically what this aspect of an electric charge is. Now we shall look as well on some of the characteristics of this specific charge and some of the experiments which were done, of course, along the historical timeline in order to quantify this a specific aspect of an electric charge. Perhaps we are going to look at a few examples on how these specific charges can be identified, and these are going to be our day-to-day experiences in our day-to-day operations. Now, particularly as I've mentioned, we are going to look at this aspect of a charge borrowing from the concept of atomic structure. And in our previous discussions, I've mentioned that basically an atom is a particular unit or division of matter which constitute of what we refer to as subatomic particles. And I mentioned that an atom basically constitute of the protons, the neutron, and then we are going to have also the electrons. Now, these are going to be subatomic particles which are going to be of our interest, especially on this specific discussion for today, whereby I mentioned that these subatomic particles are going to exhibit some characteristics, among which one of them is a charge, mass, etc. But of our interest today, we're going to look at the concept of charge, whereby we mentioned in our previous discussions that basically the proton as a subatomic particle constitute of a positive charge, and then the neutron, this one does not constitute of a charge, so therefore it's a neutral. And then the electron constitutes of a negative charge, which is going to be given using these specific notations. Now, in particular case, we are going to look at the two specific subatomic particles for the protons and the neutrons, and they're going to give us one of the characteristics of a charge, which we are going to see, of course, or rather consider in some of our discussions for today. Sorry for that. Now, in this particular case, this is one of the characteristics of charges, which, of course, is going to be seen that naturally we're going to have two specific types of charges, which are going to be regarded as a positive charge, and then we're going to have a negative charges which have been identified. So naturally we're going to have these two specific types of charges which have been identified as positive and negative charges respectively. Now this can be attributed to the concept of a proton and a neutron, which we have seen, but of course we have said that from various of course aspect of the elements or the atomic just give us elements. From various aspects of the atomic structure which we had looked at the concept of elements, whereby we said that for elements to be naturally stable, they have to obtain what we call an octet of electrons, whereby especially for the range of elements which we looked at for the main block elements, we said that these are going to be having their outermost electronic levels being filled, and therefore this one constituted what we refer to as an octet of electrons. Now some elements are going to lose electrons. Now suppose I give an example of a hydrogen which constitutes of a proton and a neutron, proton and an electron given as such. So in this case we're going to see that for this one it's going to be having one electron in its energy level. So if it loses this specific electron, then we're going to have it being represented as a proton, which is going to be given as a H positive. But if it's going to gain an electron and form perhaps another species, then we're going to see that this is going to be having, particularly for other elements, this is going to be forming what we refer to as a negatively charged ion. Therefore, the formation of ions from these specific elements are going to be constituting the formation of what we refer to as charges, which are going to be elements either having a deficit or in excess of electrons. And therefore, that's going to give us a concept of the electric charge. Now, this specific term electric, as we have been mentioning is previous, which is going to be obtained from the concept of an electron. And therefore, we're going to see that the movement of electrons within materials is going to be resulting in the transfer of charges. Now, that one having been said and done, then therefore we're going to look at some of the characteristics which you have mentioned for an electron. And of course, as I had mentioned, of course, that there were some of the experiments which were done, which of course gave an insight into what particularly an electric charge is. Now, apart from them being of two types, for the positive and negative, we're going to see that there's a way of quantifying this specific charge using the units, the standard units, which are basically the internationally recognized units for measuring of these charges. And I'm going to give them as SI units, which are given as coulombs. Now, these ones are given, named in credit of this Agostino Coulomb, who was, of course, a French scientist. And we're going to see that apart from this one, they can be given an initial or just be given a dimension of C given as such. And later on, we're going to give specific examples, of course, to illustrate on this one, on the use of these specific units which are named coulombs. Now, later on, we're going to see that Christopher, of course, this specific Charles Augustin Coulomb did a lot of work, especially on the concept of electrostatic forces of attraction and repulsion. And of course, that's going to be giving us on various laws which are going to be perhaps analogous to Coulomb's law later in some of our other discussions. And then we're going to see that the experiment of Franklin is going to be, particularly Benjamin Franklin is going to be giving us a clue on how this particular aspect of charge was arrived at. And in some of our videos, I've already mentioned about this specific kind of experiment by Benjamin Franklin, so we're not going to go into details about this, but I'm going to put a link of a specific playlist which is going to contain a range of videos that are going to assist us understand, especially the specific aspect of this experiment and how it was done. So we're going also to see that there's this laws of attraction which are going to be exhibited by this particular aspect of electric charges, whereby we're going to see that like charges, and in this case, when I mentioned the concept of like charges, this refers to either a positive and a positive charge being shown together, or perhaps a negative and a negative charge being compared together. Now, in this particular case, like charges are going to repel each other, and then we're going to also see that unlike charges, these are going to be dissimilar, or the ones which are different from one another. They are going to exhibit what we refer to as attractions. Therefore, they are going to attract one another. And this is going to be one of the aspects of the laws of attraction, which is going to be obeyed by these specific electric charges. Now, apart from that, we're going to see that in terms of units, the smallest free unit of a charge that has been identified or known in nature is going to be that charge of an electron. And of course, we're going to denote it in some of our videos, or rather in some of our illustrations using this specific symbol. And the charge of an electron is a constant which has been known. So therefore, it's going to be given in terms of 1 point negative, illustrating that this is a negatively charged particle, as I had mentioned from my previous statement. So it is going to be negative 1.602 times 10 negative 19 coulombs in terms of these specific units which I had mentioned. So in my previous statement as well, I had said that a proton is going to be a positively charged particle. Now, in as much as an electron is going to be a negatively charged particle, a proton is going to be a positive quantity of this specific charge which has been measured. Therefore, it's going to contain or have a charge of plus 1.602 times 10 negative 19 coulombs given as charge. Now, in this particular case, we had mentioned in various topics under the concept of quantum mechanics, or photoelectric effect of the idea of being quantized. Now, in this specific case, we're going to see that for us to identify a charge of an ordinary matter, then therefore it's going to be a quantized aspect in terms of these quantities of electrons. And therefore, we're going to see that the electron is going to carry 1 unit of charge for the negative, while the proton is going to be carrying 1 unit for the positive respectively. Therefore, whenever we're going to talk about the different aspects of charges, we're going to see that another kind of a matter that we're going to consider for the concept of an electric charge, then therefore we're going to bear in mind that this charge is a quantized form of integral multiples of an electron charge, which had been given in terms of this specific number. Now, in our various forms, we're going to look at different types of charges, and in forms of illustration, of course, that's going to be assisting us in trying to, of course, give an illustration of different types of charges. But we have mentioned that basically we're going to consider the two types of charges which we have given for positive and negative. And lastly, perhaps I can just give an example of this specific illustration which we are going to explain on in details in our subsequent videos. So in this case, if I give an example of a positive, of course, charge, I'm going to give it in terms of this symbol, and a negative, of course, charge, I'm going to give it in terms of this symbol. So check our description boxes for various links of other similar videos, and also kindly subscribe and engage us in the comment section so that we can share additional information regarding this specific topic. So catch us in our next video, where we're going to look at in details these different characteristics of these specific charges, and that is going to be assisting us have an overall concept of the broader topic of electricity and magnetism as I had mentioned. So that is it for now, guys. Bye, God bless you. Catch us in our next video.